All right, examples of exponential functions in real life. So think about the population throughout the years. This graph right here is representing the population beginning in 1750. In the year 1750, you had so many people. All of those people reproduced and had this, and now we had this much population. All of those people reproduced, and then we had this much population. So think about how fast that grows. Think about coronavirus. With coronavirus, one person started off infected. It infected another person. So now 2 people are infected. Those 2 people go infect another 2 people. So that's 4. And those 4 go infect more. So it's growing rapidly. The amount of infected people grow rapidly. Now, when we see a decrease, when we see, you could think in terms of a tournament. You start out with so many players and you're trying to get down to the last team or the last player. And half of them are eliminated in the first round. The other half are eliminated in the next round until you're left with none. So those are examples of exponential functions. But today we're only going to be looking at the equation, and we're going to be looking at the parts of that equation and trying to figure out the meaning behind each part. Now, the first part of this equation is A. One thing that you need to keep in mind is that this formula is not on the reference chart. You're not going to find it, but hopefully it'll still be fresh on your mind. So, and you'll have it memorized. First part right here, this variable A, this one represents your initial value. It represents your initial value. What is an initial value on a graph? An initial value, think about it. Other words for an initial value would be start, or where we begin. What was that? Sorry, I don't remember. The starting point. That describes what though on a graph? The y-intercept. That does describe the y-intercept. So the initial value, once we transfer over, tomorrow we're going to be looking at the parts of the graph, not necessarily trying to find equations from it, but just looking at the parts. Just keep that in mind. Your initial value, your starting point is your y-intercept. Okay. Now, in every equation, like in linear, you have y is equal to mx plus b. You have, for quadratics, it was x squared plus x plus c. Where is your x in this in this formula? It's what? It's a small variable up here in the corner. What is that called? Any number in that spot is called a what? It's called an exponent. Your exponent is going to represent time. But think about this. Man, there was another word I wanted to use to describe. I'll look for it later. Time. Time can be described in how many different ways? Give me some forms of time. What's up? Years, days, seconds, minutes, months, hours. Yeah. But your time could also be represented without a little bit differently. It's a unit of measurement. And I don't think that is the word I'm actually looking for. Think about that example that I just showed you about the tournament. You're going by amount of rounds. After every round, so many students or so many players are eliminated, or so many teams are eliminated. So the rounds is what would represent my time, or what would be here in the exponent spot. But I will find a better word in a little bit. Anyway, B is called your factor. B is called your factor. B is your factor. Now, just because it kind of also ties into what we went over with quadratics, a factor is what? What is a factor? That you what? Correct. It is a multiple, your multiplier. It's the numbers that you are multiplying to obtain another. Now, yesterday, because I don't know how many people I took points off for, when you were solving, when you were factoring, you would get answers and you would get down to this point where it says, I don't know, just random number, x plus 2, x minus 8. And then your answer choices said your zeros are so and so. And then your factors are, and there was a couple of parentheses. You would solve it, you get x equals -2, which a lot of people did not solve, so you lost half credit there. And then even though I got reminded you guys, you're gonna have to solve all the way. -8, you end up adding the 8, so you get x equals 8. And I would have the 2 and the 8 here. These are not your factors. These are not the numbers that you are multiplying. You are multiplying the two binomials to get the equation. These are the numbers that you're multiplying, even though some of them are variables. This is what should have been in the parentheses, -8. This is what should have been in the parentheses. Your binomial should have been in the parentheses. After you're done solving, you get your zeros. After you're done solving, you get your zeros. Your zeros are the ones that are describing where the parabola crosses the x-axis. The factors, that doesn't mean I multiply these two numbers to get the zeros. No, your zeros is after you solve. You're multiplying these binomials to get the equation of the parabola. Factors are your multiple, okay? Factors are your multiple. Learn the difference. Anyway, to obtain the factor of an exponential function, you have to take, the factor always starts at the number 1. And you're going to add or subtract r. Your factor always starts with the number 1, and you're going to add or subtract r. R represents the rate. Rate is the speed that you're increasing or the speed that you're decreasing. But that rate, think about terms of money. You hear things like interest rate, even though it doesn't really matter to you very much, but rate is always written in a percent form, okay? Rate, it's the speed that you're increasing or decreasing. I guess we could write that down. Speed of line increasing or decreasing. Speed of the line increasing or decreasing. The rate is how fast it's moving up and how slow it's moving down. The rate, the speed that it's increasing, okay? Now your factor can be, since we have that plus minus, if you take that 1 and you add the rate, you will get a line that is increasing, and it's known as exponential growth. It's known as exponential growth. You get exponential growth by adding to the 1, by adding the rate. If you add the rate, if you add any number to the 1, you get a number that is larger than 1. Let's take that minus sign. We take the 1 and subtract the rate. And all of a sudden, we're not growing, we are decaying. Exponential decay, D-E-C-A-Y, decay. If you subtract any number from 1, it ends up being less than 1. But just like whenever we were going through quadratics, it has to be greater than 1. I mean, greater than 0. So any number between 0 and 1. Any number between 0 and 1. And once again, what kind of numbers do we find between 0 and 1? Decimals or fractions. And we'll quickly find out today that it's not all decimals and fractions, just some. Okay. All right, so open up to the first page. It's a lot to soak in, but I promise it will be painless. All right, number one. So initial value is your y-intercept on the graph. We're not looking at graphs, so we're talking about initial value. What is the initial value here? 1,200. 1,200. It will always be the number in front of the parentheses every time. What is the factor? 1.25. Now I'm going to put that 1.25 in parentheses, not because we're actually going to do anything to it, but when I put it in parentheses, I'm reminding myself that it's the factor is the number in the parentheses. Now, to get the factor, you have to have a rate, and you have to have a rate. But if we have a number greater than 1, or did we add to the 1 or did we subtract from the 1? Add. So we're looking at an exponential growth. We added to the 1. Now you get the factor by adding the rate. So I'm going to put the 1.25 right here. Some of these are pretty simple where you can actually do the math in your head. Some of them aren't. So I believe this one is, what did you add to the number 1 to get to 1.25? 0.25. But notice here where you have the word rate, right under that line, it says percentage. Your rate is always written as a percent. So I need to take that 0.25 and convert it back to a percent. There are 2 different ways you can do it. What's one of them? Does anybody remember how to switch it back to percent? There you go. Fastest way, in my opinion, is knowing that you move it back. 1, 2. Take that decimal, move it back twice, and it becomes 25%. I'm going to show you both ways a couple of times, and then from there you choose, okay? The other way is, in case you forget, does it go to the back? Does it go to the front? Do you move it up? Do you move it back? You take the 0.25, and anybody know the other way? You multiply by 100. So I'm gonna actually put the 100 in parentheses instead of writing X 100. And then that should give you 25 for the 25%, okay? You could use either way. Either remember that you gotta move it back or multiply by 100. All right, questions? Next one. What's my initial value? 55. Okay, what's my factor? All right, now is 1.02 larger than 1 or less than 1? Larger, so that means we have growth. Now that 1.02, we do not convert that to a percent. We use it to find that percentage. What did I add to 1 to get to 1.02? 0.02. Okay. Now, even though that's my rate in decimal form, you have to give it in percentage. So I take the 0.02. I can either move it twice move the decimal 2 to the back, and I get what? 2%, or take the 0.02 and multiply it by 100, and it should give you 2. Questions? All right. Let me know if I'm going too fast, if you need me to slow down so you can copy. Number 3, what's my y-intercept? 100. What's my factor? 5/2. Now, it's a fraction. Most of us will automatically say decay because you see a fraction. But go ahead and convert every single fraction to a decimal. And what do you notice? What does 5/2 give you as a decimal? It gives you 2.5. And 2.5 is definitely larger than 1, so that is growth. Okay. Hopefully you can still do this one in your head. What did you add to 1 to get a 2.5? 1.5. 1 plus 1 plus 1 is 2, 1.5. All right. So I take that 1.5. This time, if I move the decimal twice, I end up with the gap. What happens when you end up with the gap? Put a 0, fill it in with a 0. So that represents 150%. And before anybody asks, yes, you can have a percentage larger than 100. 100 is not a max. Or you could take the 1.5 and multiply it by 100 and you'll get your 150. But since I like doing the decimal movement, I'm not going to show you the 100 anymore. Okay. All right. Number 4, trick question. Where do we start? If there is no number in front of a parentheses, you always fill it in with the number 1. So my initial value is correct 1. What's my factor? 6/5. And 6/5 is what as a decimal? Yeah, 1.2. Definitely larger than 1. So we're looking at growth. How do I go from 1 to 1.2? I added 0.2. Now I have to convert it to a percent before moving on. So since I end up with a gap, that is representing what? 0. So we get 20%. Usually by the end of this example, somebody's asking me, what about the X? We're not actually working with the X today. Right now, we're getting used to knowing what the initial value is, knowing that the initial value also represents the y-intercept, and knowing that the factor is not my percent. The factor is the number that I'm multiplying to get to the next value, but the rate is my percentage. Okay. Next page. Number 5. Where do we start? 3. And what are we multiplying every time? 4. Factor is a multiple, so we're multiplying 4. Is 4 bigger than 1? So we have growth. What did I add to 1 to get to 4? 3. Now, 3 doesn't have a decimal that even exists. When you have a whole number, you have to make it a decimal by placing a decimal there at the end. 3 is the same as 3.0, right? So I move it twice. I have 2 gaps, so I fill both gaps in, and we get 300%. Questions? 6, where do we start? What are we multiplying? 3.75. Factor is a multiple, we're multiplying 3.75. 3.75, is that larger or less than 1? Larger, so we're looking at exponential growth. And what did you add to 1 to get to 3.75? 2.75. 2.7. All right, take the 2.75, move that decimal 2 to the back. And what percentage did we get? 275. Ready? All right, number 7. Where do we start? 1. My starting point, my initial value, my y-intercept is 1. What are we multiplying? 0.085. Very important that you notice it's 0.85. Exponential growth or decay? Decay, it's less than 1. 0.085. All right. Once we get into decay, once we start subtracting, this is where the math really comes in, because sometimes it's not always easy to do this kind of stuff in your head to try to figure out, well, what do I add to 0.085 to get to 1? No. When that happens, let's say, for example, test grades. Your max test grade is 100, so I'm going to use that as an example. And your actual grade, I'm subtracting something, and your grade was 30, because that was the average test grade yesterday. Let's say 37.2. That's not going to be exactly easy to do in your head. What would you do to solve that, though? You would subtract that from 100. Even though this is your answer, you could also interchange it. If I take 100 minus 37.2, I get my grade. And what is that? What's up? 62.8. 62.8 is the actual grade, even though I had to take 37.2 points away. Or wrong way. I had to take 62.8 points away to get to the grade of 37. But anyway, same thing here. I'm going to take the 1 and subtract the 0.085. By doing this, I want to do this separately because I don't want you guys to get in the habit of placing it here. The 0.085, just because it's in this spot now, does not represent the rate. It's still the factor. We're just working backwards to get the rate once again. And what is 1 minus 0.085? 0.915, 0.915. And the 0.915, this is the number that I have to convert back to a percentage, not the factor. So if you do this to find the value, make sure you know that your answer is the rate, okay? Not the 0.085. So now let's convert it back. So 0.915 as a percentage is what? 91.5. Ready? Number 8. What's my initial value? What's the factor? 2/3. 2/3 as a decimal is? Okay, we're gonna go ahead and use 0.67 because it's 6666666. And that is what? Greater or less than 1? It's DK. All right, so I take that 0.67. I remember that it's only the factor. So to get the rate, I have to subtract it from 1. So 1 minus the 0.67, even though the 0.67 is my factor, will give me the rate. What is the rate? Point what? Yeah, 0.33. So which one am I going to convert to a percent? The 33 or 67? 33. Move it 2 to the back. 1, 2. And you get 33%. Good. Almost done. Where do we start? 1200. What do we multiply? 0.75. Is that my percent? No. Is it greater or less than 1? Less. All right. 0.75. I'm gonna think in terms of dollars. What did I spend to go from $1 to 75 cents? 25. Some of them are pretty easy, so I'm not gonna actually do the 1 minus, but if you need to, go for it. And that gives us what percent? 25%. Good. Questions, concerns? All right, number 10, what's the initial value? 55. What is my factor? And do we have growth or decay? Decay. If I have $1, what did I spend to get to 85 cents? 15. Let's convert the 15 to a percent. And what do we get? 15%. Good. Pretty quick, pretty simple. Even though this is pretty straightforward, I've had a lot of people make mistakes. So please move the decimal. Even though you know you could do that in your head, move the decimal anyway. You'd be surprised how many mistakes I've seen today. All right, number 11. What's my starting point? What's my multiplier? 1/4. All right, but 1/4 as a decimal is? Which is showing growth or decay? All right, so factor is 0.25. What did I spend for my $1 to get to 25 cents? So 0.75, move your decimal back to 1, 2. And we get 75%. Last one. Ready? Number 12. What's my starting point? What's my factor? Growth or decay? All right. And what is the rate? 0.67. And now 0.67 converted as a percent is what? Good. 67%. You are going to glue this on